All right, Jonathan, help us. We are evaluating 3 times 1/2 to the x power with these x values. Remember, the domain is all of your x values, so you're going to put all of these values into x. Can't see anything. So the domain is all of these values you're going to put in for a value of x. And basically what we're doing is we're kind of doing like 5 little mini problems. Jonathan V, help us do the next one. Jonathan, tell us what to write.
So first you start with the original 1, 3, multiply by 1 and over 2 to the power of -1.
-1.
Then you would first do the exponent.
Okay.
You would end up getting 1 over 2.
Raise your hand if you got 1 over 2.
Oh no, -1 over 2.
So 1/2 to the -1 power. There's a couple of ways of doing this problem. Yesterday I showed you guys how to move the whole thing downstairs. Yes? Let me show you a second way and you get the same answer, okay? I'm not breaking any rules. These are all the laws of exponents. Rules of exponents. Because this is outside the parentheses, you can do the power rule. Everyone say power rule? What does that mean? Essentially, it means that you can essentially distribute this -1 to its exponents. Okay? Something like this. If you had like 2 to the 2nd power times 2, then you just multiply those numbers. That would be 2 to the 4th power. So essentially, that's what we're doing. We're just distributing this 2, or distributing this -1. So this one has a power of 1. So this will be 1 to the -1 power over 2 to the -1 power. Class, what does the negative exponent tell you? You just switch where it goes. Let me tell you my story again. Let's pretend you live in a 2-story house. Let's just say your parents now say, oh, you're moving to the bedroom downstairs. So you pack up your room, you put them in a box, you put a tag on it saying go to bedroom number whatever it is. But once it switches places, let's just say you're in the upstairs, you can go downstairs, you take off the tag. It's in the right location. So this becomes 1 to the 1 power, and this becomes 2 to the 1st power. Class, what's 2 to the 1st power? 1 to the 1 power. So this is 3 times 2. Raise your hand if you got that. And if you multiply that, you get what? 6. So -1, 6. All right, Lupe, help us with the next one. Were you here yesterday? You want to try it? All right, tell me what's all right.
3 parentheses 1/2 parentheses 0.
All right, let me ask the class a question. Don't say anything. You're going to either show me 1 or 0. What's 1/2 to the 0 power? Yeah, it's 1. So, Lupe, go ahead and simplify.
3 1/2.
Anything to the 0 power, Lupe?
Oh,
1. And then 3 times 1. 3. So I have 0, 3. And then the positive integers should be a lot easier, right? Annalene, go ahead and tell us the first one. Which is 3 over 2. Now, for those who struggle with the number sense, years ago I had a student tell me, I said, what's 3 halves? And they said, it's a number between 2 and 3. You and I have $3. We split it. How much is it? 150, 1.5. So I only like decimals to help you with that number sense, so you're not like that student who thinks that 3 halves is a number between 2 and 3. Okay, 2. Jonathan H. What is 1/2 to the second power? What does this mean? How many 1/2s do you have? So what's 1/2 times 1/2? You're not adding, you're multiplying across. What do you get? 1/4. Remember, if you applied the power rule, that would have been 1 squared, which is 1. 2 squared is 4. And Jonathan, 3 times 1/4. As a fraction? Make 3 a fraction, put it over 1, multiply across. 3/4. Class, what do I like better? The reason why I like fractions is because the unit circle next semester is all about fractions. You will get annihilated with not knowing fractions. So that calculator better help you with those fractions. 2 more. Come on. Melissa. Yep. What did you put in here? What is 1/2 to the third power? She can do it. And only 3 times 1/8? 3/8. And 4. Jocelyn?
3 times 1/2 and 3 times 1/16 is equal to 3/16.
Nathan, in about 30 seconds, is going to ask you for decimals for these y coordinates. In 30 seconds. Okay, let's do something different. Let's graph it. Let's graph it. Wherever you got space in your notes, let's graph it. Because we got a bunch of ordered pairs now. Let's see what our exponential graph looks like. And I'm thinking ahead. If you look ahead, look here, guys. I noticed that all my y values are what? They're all fractions? They're all positive, which means that we're actually going to have an asymptote here on the x-axis. Okay. Let's use a different color pen. Let's use this color. Negative 2, 12. Left 2, up 12. 2, 4, 6, 8, 10, 12. And again, I only use pen because it's helpful for you guys to see it. If I were a student, I would be using pencil. Negative 1, 6. Left 1, up 6. 2, 4, 6. Okay, this one I'm putting in red. Why do you think I'm doing that? What does this represent, class? Huh? The y-intercept. Super important. It is the most important point for an exponential graph. What's the most important part of the exponential graph, class? It's super easy to find because your x is 0, and you put anything in 0 as your exponent. We learned yesterday that your exponent will always be a variable. Something to the 0 power is always 1. In this case, it has a, it was moved up 3. Okay, then I got 1, 1.5, so write 1, between $1 and $2. Nathan, 3/4. Yeah. Okay, so, if I have 3/4 of a dollar, let him think. Yeah. 3/4 out of a dollar is 75. We're okay? Nathan, 3/8. You have a calculator. That's what I was asking.
It's like 0.375.
Okay, 0.375. 3/16. Point what?
0.25.
Is your calculator ending?
Oh, 0.1875. Never mind.
Everyone say smooth. Your curve better be smooth. And it's approaching 0 though, right? There you go. So we have our exponential graph. Let me point out some very big ideas here. Put your finger on the y-intercept. You should actually have it on 2 locations on this paper. Here is your y-intercept graphically and actually through the equation. So, yeah, we did all the algebra work, but that's where it is. Okay?